Okay, we are live. If there is anybody in the chat section, please let me know if I am audible. Just give me a quick thumbs up in the chat section so that I'll know everything is fine with my stream. Let me know if I'm audible. Okay, so everything is fine. Let's just wait for 1 or 2 minutes so that more students will gather and then we'll start our session. Okay, so guys, we have discussed about decision trees and where we are going to use decision tree, that we can use it for classification, and also we can use when we have a categorical feature as well as if we have a numerical feature. So we have seen that in decision tree. And later on, we have discussed about entropy and information gain. What was entropy? Entropy is basically is a measure of impurity in the data set. So if I'm taking a split, so I'll use information gain for that, and information gain I'm going to find out using entropy, right? So let's suppose if we have two data sets, two splits, I'll find out information gain in each of the split, and the split which has more maximum information gain, I'll take that split in consideration for my decision tree, right? So if that's clear, just let me know. Right, so if you remember, we have discussed one question. So we have one question with you. I told you one question, and the question was, let's suppose if I have two splits, let's suppose if I have data set, let's say 29 and 35. So at the start, I have two splits. In this, I have 29 positive and 35 negative. That means we have in total 64. Using one condition, let's say using one feature A1. When A1 is true, it gets split. So we have two conditions. A1 is true and A1 is false. So we have used the feature A1 to split this data set. And then we have split. We got, in this case, we got 21 positive and 5 negative, right? And 8 positive and 30 negative. 8 positive and 30 negative. These get split, right? This is one of the split. If I'll talk about another one using A2 feature, let's suppose A2 feature, again I am splitting the same data set, 29 positive and 35 negative, right? Using this A2 feature, I am splitting. If this A2 condition is true, then they get split into, the split is 18 positive and 33 negative. 18 positive and 33 negative, right? And if it is false, then 11 positive, 2 negative. 11 positive, 2 negative. And overall, it is making 64 examples. True, false. So I told you to find out information gain in both of that, right? I told you to find out information gain, right? So let me know what would be the information gain in both the cases. Have you solved it by yourself? Just let me know what would be the information gain. So I told you, for information gain, you have to find out entropy at every split. You have to find out entropy here, entropy here, entropy here, right? So you would, using that, you would get information gain. So just let me know if everybody has found out what is the information gain in this case, because information gain helps me to decide that which split I'm going to take for consideration or for further splitting of decision tree. Let me know in the chat section. So here, let's consider this set as S and S1 and then S2. If I'll find out entropy at S, we already have solved it, but let me tell you once again what is entropy. Entropy is minus summation Pi log Pi. Pi is the probability of classification, right? So here we have, it would become minus 29 by 64 log to the base 2, 29 by 64, because the formula for entropy is summation I varying from 1 to n Pi minus log to the base 2 pi. Pi is the probability of a particular class, right? 29 comma 64 minus, and then we have 35 by 64 log to the base 2 35 by 64. Let me, yeah, right? So this is entropy at S. Now you can solve it using calculator. We have solved previously as well. That what would be the value for this? Just tell me what would be the value, because we have already solved it. So I know that this value would be 0.99, right? And I have considered this set as S1. So entropy of S1 would be, what would be entropy of S1? Guys, we already solved it. Let me know what was the entropy at S1. What would be entropy of S1? So because it has 21 positive and 5 negative, so classes probability would be 21 by in total they are 26. So classes probability would be minus 21 by 26 upon into log to the base 2 21 by 26 minus 5 by 26 log to the base 2 5 by 26, right? Now I can solve it using calculator, right? Calculator is allowed in the GATE exam, so you can solve it using calculator. So this would give you the value 0.71. Now you have to find out entropy of S2, right, for this set. So it would become 8 by, because these are in total 38. So minus 8 by 38 log to the base 2, 8 by 38 minus 30 by 38 upon into log to the base 2 30 by 38, right? This would be entropy of S2. So on solving, what would be the value here? Just solve it and let me know. What would be the entropy value here? If I'll solve it, I'll get the value 0.74. Right, 0.74 is the entropy. Now, if I'll find out information gain in this split, information gain, either I can write down information gain or I can use gain only, right? So let me write down gain, and I am finding out gain for this subset S and using the split A1, right? This is a notation. Gain S comma A1. So what is the formula? The formula is entropy of S. Entropy of S minus summation SV upon cardinality of S, right? This is the formula which I am writing here. Entropy of SV, right? And V belongs to classes. V belongs to classes. You can write down here V belongs to classes. Right? This is a formula. Now I can put down all the values. Just let me know, guys, if this thing is clear, this formula is clear to everybody. So what would be, it would become, what is entropy of S? Entropy of S is 0.99, and because we have two classes here, sorry, in two partition I have divided it into. So if it would become 0.99 minus how many values we have in this, 26 upon 26, and in total we have 64 values. 26 by 64, and entropy at this S1, that is 0.71 minus, and in this case we have 38 data points, 38 examples upon 64, and entropy at this 0.74, right? So this is the information gain. V belongs to, either I can write down this as class or V belongs to the values. V belongs to the value. That means how many values I have splitted that feature, right? So if I'll solve it, what would I get? On solving, you can solve it using calculator. You would get the information gain 0.27. We have already solved it in the last class. Just let me know what would be the information gain in this split. Just let me know, guys, in the chat section, what would be the information gain here. Again, you have to do the same thing. You have to find out entropy of S. Let's consider this set as S, S1, S2, because I have already find out entropy of S. So there is no need to find out again and again. So I can write down here as well. Entropy of S is 0.99. But if I'll talk about entropy of S1, entropy of S1, that would be, because here if I'll count the data points, these are 8, 9, 10, 11, 51. Here we have 51 data points, and here we have 13 data points in total. 13 examples. So I can write down here minus 18 by 51 log to the base 2, 18 by 51, right? Minus, and we have 33 different class, 33 by 51 log to the base 2, 33 by 51. I can solve it using calculator. That would give me entropy at this split. That means impurity in this split. So that would become, because I have solved by myself using calculator, so I got this example already. So we'll get 0.94. So you can see that how much impurity we have, right? 0.94 impurity, because you can see that half of the values are negative, right? And about 1/4 are positive. Entropy of S2, again I can find out entropy of S2. So what would be entropy of S2 for this 11 and 2, 13 data points? So I can write down here minus 11 by 13 log to the base 2, 11 by 13, minus 2 by 13 log to the base 2, 2 by 13. Now again using calculator you can find out the value. So what value you would get? You would get 0.62. Right, so these are my entropies. Now the next thing is I have to find out gain using this A2 feature. So using this A2 feature, gain would become S of A2. Again I know the formula, entropy of S, that is 0.99. 0.99 number of values in this set. S1 has 51 values, 51, and in total we have 64 values. Entropy of S1 is 0.94 minus, in this set S2 we have 13 values, 13 upon 64, and in this we have 0.62 entropy. Now I can find it using calculator. So on solving you would get it as 0.12. So you can see that if I have splitted the same data set, same set of examples using A1 feature, I got information gain 0.27, and if I have splitted same data set using different feature, that is A2, I got information 0.12. So which split I'm going to use? I'm going to use this A1 split because it has maximum information gain. Right? So do you guys get it that why I am using this split A1 instead of split A2? Okay, so let me know guys if there is any question in the chat section. Just let me know so that then we'll move forward. Okay, so you can take down notes and all. Let me give you a side. Just let me know guys in the chat section if there is any question or anything. Just let me know. So I hope these calculations are clear. I know these are little bit more complex because we have solved for each of the split, but there may be required. You just have to practice these problems, because if you would see GATE 2024 paper, you would find out that there is one question based on information gain, and that is a 2-mark question. So that is important that you would understand this topic. So understand this topic. Okay, I hope you guys got this. Just let me know guys in the chat section if there is any question or any confusion. Okay, so if everything is clear, so in this problem you can see that I have already split it, that 21 positive, 5 negative, 8 positive, 30 negative. Now let's try to find out, let's try to do a split let's try to find out, let's try to form a decision tree based on a data set given to us, a raw data set I'm going to use. So we have this, okay. So we have this data set: day, outlook, temperature, humidity, wind, tennis. Right? This is a data set given to me in which I have 14 examples. So on day 1, we have some examples here that in a particular day is sunny, day is hot, then the humidity is high, and day is weak, then player hasn't played tennis. Similarly, if day is sunny, on a particular day, the day was sunny, day was hot, and high humidity and strong wind, the player decided not to play. Right? The day is overcast and hot temperature, high humidity, weak wind, player decided to play tennis. So we have these examples of previous 14 days. Now, for a particular outcome, if we want to decide that either a person is going to play tennis or not, so how we are going to do that? There is one thing we can do using naive Bayes, right? Naive Bayes is also used, and we have done problem for this kind of a problem on naive Bayes algorithm as well. But let's form a decision tree for that, right? So what is? So you can see that playing tennis, in this, 2 no, 3 no's, 4 no's, 5 no's. So in this we have 5 no. I can say that 5 no, and how many yes? 3, 4, 5, 6, 7, 8, 9. 9 yes. On the given 14 days, I have 5 on 5 days player is not playing tennis, and on 14 days player is playing tennis. So we have this data set. Now I have to split it. I have to split it using the features outlook, temperature, humidity, wind. So what would I do? I'll find out information gain for each of the feature, for outlook, temperature, humidity, and wind. And then I'm going to decide that which feature I'm going to use, because there may be a possible, because we have seen that we can use outlook, we can use wind, we can use any of the features here at the start. But I want to I want that my decision tree depth should be minimum, there would not be any overfitting, and I'll get uh, I'll get optimal results, right? So what would I do? I'll form a I'll find out information gain for each of the split, right? So let's do that. So we have this table. So if I'll talk about, let's say if let me form, so playing tennis, uh, using tennis, in which I have how many yes? 1, 2, 3, 9 yes and 5 positive. 9 positive and 5 negative. So let's say I am splitting it using the feature outlook. Outlook feature. If I'm splitting it using outlook feature, so we have 2 sunny, 3 sunny. So in these 3 sunny days, so let's say uh, let me take the feature here outlook. Let me take the feature outlook. So I'm writing here outlook feature so that you would understand that why I'm taking this outlook feature, because it is at the start. So I'm splitting it into sunny, overcast, overcast and rain, right? So if I'm talking about sunny, so we have these 3 days which are sunny, this, and out of these 3 I have all 3s are no, right? On any of the sunny day the person is not playing tennis. Or do we have, okay, we have 4 sunny days, 1, 2 and sunny, sunny, and we have 5, sorry, we have 5 sunny days. Out of that we have 3 positive and 2 negative. So I can say that here, sorry, 3 negative and 2 positive. It is in color, so that's why I felt like that I have left. So 3 positive, because you can see that this is sunny, this is sunny, this is sunny, this is sunny, and this is sunny. So we have 2. Okay, I have written. Let me write down this simply. So if the day is sunny, so I can say here I got 3 negative and 2 positive, right? If the day has overcast, outlook is overcast on that particular day. So let's talk about overcast. So first I'll see that in how many cases we have overcast. So let's see. This is overcast, this is overcast, this is overcast, and this is overcast. So we have all 4 days are overcast and all are yes. So here 0 negative, 4 positive, right? And if I'll talk about, let's talk about uh, rain, right? We have these 3 are rain, these 3 are rain, this one is rain, and this one is rain. So we have again 5 rains. Out of those 5 rains we have 3 yes and 2 no's. So that means 3 positive and 2 negative in case of rain. So now I want to find out information gain for this outlook column, outlook feature, right? So tell me guys, what would be the information gain here? Just try to find out by yourself that what would be the information gain in this case. Let me know. So what would I do? Let's take this as S, or you can say that, or yeah, let's take this as S, S1, S2, S3, right? Entropy of S would be entropy of S. Sorry, I can find out entropy of S here. What would become? Minus 9 by 14 log to the base 2, 9 by 14, minus 5 by 14 log to the base 2, 5 by 14. Right? That would be the entropy. Now you can solve it using calculator. What would you get? On solving, you would get 0.940. Right? Now you have to find out entropy at S1, S2, S3. Right? So what would be entropy of S1? Let's find out entropy of S1. Entropy of S1, 3 negative, 2 positive. So that means minus 3 by 5 log to the base 3 by 5 minus 2 by 5 log to the base 2 by 5. So if you will solve it again using calculator, you would get the value 0.971. So you can see that here 50% chances, 55 or 60% chances, because we have 3 negative, 2 positive. So that's why we have so high entropy, so high impurity in this case, right? So you can understand that. And you would find out entropy of S2. What would be the value of entropy of S2? Because 0 negative, 4 positive. So it would become 0 by 4 log to the base 2, 0 by 4, or and plus 4 by 4 log to the base 2, 4 by 4. Because this whole term would become 0, because this is 0, and log 1 would become 0. So you will get this entropy of S2 at 0. So because you can see that we have 100% positive and 0% negative. So that's why we have 0 impurity in this case. And similarly, I can find out entropy of S3. Entropy of S3 would be 3 positive, 2 negative. Again, we will have the same thing which I have in entropy of S1, 3 by 5 log to the base 2, 3 by 5 minus 2 by 5 log to the base 2, 2 by 5. On solving, you would get the value 0.971. Right? This is a value. Now you can find out information gain for this case. What is the formula for information gain? So we have solved so much about this gain. So I am trying to find out gain of set S using the feature outlook. Right? Using the feature outlook. So what would I do? I'll take entropy of S, that is 0.9540, minus number of elements in the set S1, that is 5, and in total we have the elements 14. 5 by 14 into entropy of S1, 0.971. And in the next case, we have 4 elements, 4 by 14 into entropy, that is 0, minus. In this case, again, we have 5 elements, 5 by 14 into 0.971. Now I can find out this value. So what this value would be? On solving, you would get this 0.247. 0.247. This is a value for the entropy here. Now, what would you do next? So in this case, in this outlook column, for this outlook feature, you would get the entropy, that is 0.247. Now you have to do the same thing. You have to find out entropy for temperature, entropy for humidity, entropy for wind. So let's just find out by yourself and let me know which feature is important. Just try to do that. Let's take time and find out entropy of temperature, entropy of humidity, and entropy of wind. And you can take notes from here if you need it. So guys, do you get it that how we have find out information gain in this column? So now I have to find out information gain for temperature, humidity, and wind. So you can try by yourself and let me write down here that what are the entropies. So for this information gain, S comma outlook is 0.247, because I already solved it. So I know that if I'll split it using gain S comma with temperature feature, using this temperature feature, I got this information gain when I have solved it. You can solve it by yourself. And For temperature, I got this 0.029. That means I am getting so less information using this temperature feature. And if I'll find out gain using this wind feature, humidity feature, humidity feature, you have to do the same thing which I have done for Outlook for all these features. For humidity, it would be 0.151, 0.151. And similarly, I can find out gain for this wind feature. Gain for this wind feature, that is 0.048. Right, so now you can see that for the information gain for the Outlook feature is 0.247, information gain for the temperature feature is 0.029, information gain for humidity feature is 0.5151, and for wind it is 0.048. So which has maximum information gain? That is Outlook. So we are going to divide it using the Outlook feature, right? But at this point also we have to divide it further, we have to form a complete decision tree, right? So that would be the problem. So let me remove it. So write down these information gain for temperature, humidity and wind, then we'll see that how we are going to divide it further, this table. Just write down this and let me know guys there if there is any confusion in the chat section. Okay, so that means I am going to divide my table using this Outlook feature, and I have started with I have 9 positive and 5 negative, right? And then I have divided it into overcast, that is overcast. In this we got 4 positive, and here we have sunny, in which we have 3 negative, 2 positive. And that means 3 on 3 days the person is not playing tennis, on 2 days person is playing tennis. And when the day is rainy, we have 3 positive, 2 negative, right? So we do not have to expand, we do not have to take further decision tree on this overcast form, because we know that in on this day player is going to play tennis, that means answer is yes. But for on the sunny day and on the rainy day we have entropy so high, so we have to find out that uh, on which feature I have to further divide. So now we are left, let's remove this Outlook feature because we do not need the Outlook feature. So what will we do? We'll use temperature, humidity or wind. So now next thing would be I have to find out information gain for this sunny feature, right? Now previously what I have done, just understand this very carefully, that when I have only that player is playing tennis or not, so I am checking Outlook, temperature, humidity and wind, right? Now in this case for this sunny day, let me first see that in how many days we have sunny. This is sunny, these two are sunny, and we have this one is sunny. So we have 5 examples on which we have days sunny, right? So now I have to see that either I have to divide this sunny over temperature, humidity and wind. So what would I do? I'll find out gain for sunny day and temperature. Now you would ask that how would I find out gain, sunny comma temperature, right? That would be a problem. So now you can see that sunny is what? On this sunny day we have 3 negative, 3 negative, 2 positive. Now for the temperature, temperature is hot, cool and mild. Or let's say instead of temperature I am expanding it over humidity, right? Because it is only two values, high and normal. There is, so that's why I'm doing that. So sunny is high and normal. I am taking here the feature humidity. So here I am saying that humidity is high and I am dividing it, and here humidity is normal. So when humidity is high, so you can see that in this case we have high, in this case we have high, in this case we have high, and after these 2 cases we have normal, right? So we have 3 highs. So in this 3 high we have 3 negative and 3 negative and 0 positive. And on normal day, you can see that only you have to consider in which column, in which row we have outlook feature sunny. I have to consider that. Now here we have normal and normal. So that means we have two positive, sorry, here we have 3 positive and 0 negative. Here we have 2 negative and 0 positive. So that means when humidity is high, we have all the values positive, and when humidity is normal, then we have 2 negative. Now I can find out information gain. What would be the information gain? I'll find out entropy here, entropy here, entropy here, right? So here entropy would be 0, here entropy would be 0, and here already I have found out what was the entropy when I have found out. That is entropy of sunny, 0.971. 0.971 was the entropy when I have previously find out that. So now if I'll find out gain, now what I'm finding out, gain as sunny, comma, humidity, right? So I have already splitted my set S into sunny. Now I am splitting that sunny into humidity. So what would I get? I'll get entropy as entropy of S, entropy of sunny, that is 0.971 minus something into 0, something into 0, I'll get 0. So we'll get information gain 0.971. Similarly, I have to find out information gain for temperature, sunny comma temperature and sunny comma wind, right? So that means I just have to find out gain as sunny comma humidity. I already find out humidity, and gain as sunny comma wind. Just try to do by yourself. Just don't think if I am writing it, you do not have to do by yourself. Just try to do by yourself, because just try to take one data set and try to form a decision tree all by yourself by finding out if for each of the feature, information gain, entropy, all those things. That would make it very clear to you. So in this case, because I have already find out for a sunny, if I'm taking the temperature into consideration, I got 0.570 as the information gain. Humidity I already find out, that is 0.971, and for wind we have 0.019. 0.019. Can you tell me with which feature I am going to split? Let me know of this sunny feature, with which feature further I am going to use for the split. Let me know in the chat section, guys. Temperature, humidity or wind, which feature I am going to use? So here you can see that the information gain is maximum. So I'm going to use that. So that means what I'm going to do, let me remove this, guys. Okay, so here I am going to remove, I am going to divide using the which feature, because I got humidity. And in this humidity, when humidity is high, humidity is equals to high and humidity equals to normal. Humidity equals to normal, right? So we got these two values. So that means I have divided using the humidity feature. When humidity is high, we got 3 negative and 0 positive. And in this case, we got 2 positive and 0 negative, right? So that means when humidity is high, we are not going to play tennis, and when humidity is normal, we are going to play tennis. So you can see that our leaf node is pure node, right? Where we are going to stop. I do not have to divide it further, because you can see that here we got the pure node, pure leaf. There do not, we do not have any impurity here, or I can say that its entropy is 0. Similarly, for this overcast, we are not going to divide it further because this is a pure leaf, pure node. We do not have any impurity in this. Now, but this rain column, again, what would I do? Now, again, the problem is for this rain, I have to find out What I have to find out? I have to find out gain S comma S rain comma temperature equals to gain S rain comma humidity and gain S rain comma wind. You have to find out these three values to get to know that with which feature you have to split at this rain point. Let me know guys if you are able to find out the information gain here. So you can just solve by yourself. I know that because wind would be gives you maximum entropy. So you would get wind is weak and strong. So if I'll split using wind is equals to weak and wind is equals to strong, I'm going to divide it into that. Wind equals to strong. So let's see when we have a rain column. Let's go back to our table. Let's see where we have wind, because I already solved it. So I know here rain we have in these three column, in these three rows we have rain. This one gives me rain and this one gives me rain. Right now, let's see weak and strong. So when we have weak wind, we are going to play tennis. Weak, weak, weak. That is yes, yes, yes. But when we have strong wind, you can see that on a rainy day we have these two strong winds, so we are not going to play tennis. So that means weak would give you 3 positive, 0 negative, and here we give it gives me 2 negative and 0 positive. So that means this would become a pure node, right? Pure node means that we are not going to split it further. There is no need to do that because we got our result 3 positive. That means we are going to play tennis in this day. We are not going to play tennis. So this is a complete decision tree for this table. So guys, to understand or to practice all these impurity, all these entropy information gain, just try to find out whole table. Just try to find out whole table for a particular table. Just try to find out complete decision tree so that you would understand all the mathematics behind it, right? I hope you already understand, but it helps you to solve the problems quickly, right? So take one table and try to split, try to find out the whole decision tree by yourself. So this is the table. Just write it down and let me know guys in the chat section if there is any question. Let me know guys in the chat section if there is any question. Okay, so let's move forward. So we have these two tables. So just take a screenshot and try to find out decision tree by yourself. This is a practice problem because in the last session students asked me, ma'am, please share some practice problem as well. So that's why this is a practice problem. You have to find out the complete decision tree for this problem. So just take a quick screenshot. And guys, if there is any confusion in decision tree, you can ask me in the chat section. Okay, so just try it by yourself. If you would get any confusion, we'll discuss in the next session, right? Okay, so these are the, yeah. So I told you the formula for computation of gain. This is Okay, I have solved it completely. So let me tell you that how we are going to find out. So you can see that here we have three classes: mammal, one, two mammal, and we have fish, reptile, and amphibian. So we have four classes. So this would get little bit lengthy for you because you can see that we have four class label. In the previous one, we have only two class label, yes or no. So that would get little bit lengthy. Just let me know if I'll help you to solve it for the first feature, or should you should you do it? Would you do it? Just let me know in the chat section, guys. Then we'll discuss it. Otherwise, you can do by yourself and we'll discuss it in the next session. So basically here you have to find out, let's suppose here class label is, so that means you have to divide it into mammal. Uh, so that means we have two mammals and two mammals, and this is reptile, one reptile, and one two fish, two birds, and how many amphibians? Three amphibians. Right. So how many examples we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have two mammals, one reptile, two fish, two birds, and three amphibians. So this is my if I'll find out uh, the entropy at this point. What would be the entropy here? So you can see that in total we have entropy of a set S. So what would we do? Minus P amphibian log to amphibian. So amphibian is 3. So minus 3 by 10 log to the base 3 by 10. Minus P bird log to P bird. How many birds we have? 2 birds. So 2 by 10 log to 2 by 10. And then we will find out for fish, mammal and reptile. We'll get the entropy 2.264. And in the last class, okay, so regression. So if we have a numerical input, okay, I'll tell you that as well. If we have a numerical input, okay, so let's first discuss this. I already told you in the last classes that if my feature, if I have binom or I can say that binary tree, then only I get the entropy between 0 and 1. Otherwise entropy can be more than 1, right? So that here we have 2.2464. Right, so now you can find it. Okay, so someone has asked that if we have a regression, so let's suppose if we have a marks, using the marks, so this marks is my numerical data, and using this marks category, if I am getting that students get A grade, B grade or C grade, out of that I'm dividing. So let's suppose I got the marks, let's say 15, 25, out of 30 we have marks 28, and we have 16, 12, 10, 5. So we have these marks, right? So what would I do? Because these are numerical data, so there may be a possibility. So I'll divide it into sections. Let's say if I'll divide it into 3 sections, or because in decision tree it is not suggestible that I'll divide it into more than 3 sections, because then it would get more difficult to find out entropy and all. So what would I do? I'll write down here 0 to 10 and 10 to 20. 20 to 30. So now you can see that it would become categorical feature. So I can see that how many values I have between 0 to 10. Let's say 2 values. And 10 to 20, let's take it as 11 to 20 and 21 to 30. 11 to 20 we have 1, 2, 3. 3 values we have here and 2 values we have here. Right? So if we have a numerical input, numerical feature, then I can divide it into categories. And if we similarly, if we have numerical output as well, then we can also divide it into categories. I hope this thing is clear to everybody. And here as well, guys, in the last session I told you, let's suppose, because we have 5 values here, if I do not want to take 5 values once at a time, if I do not want to divide, so I'll take mammal, reptiles and amphibian in one section and fish and bird in another section. I first divide it into these two, and then I get divided into mammals, reptiles and amphibians. So it's up to you if you want to do that. Okay, so we when we'll do in practical, let's suppose GATE exam does not require the practical implementation, but when we do in practical, we'll try to do that for to take each of the combination which would best result for me. But right now information gain is enough to understand that which feature we are going to use for split, right? So yeah, that's all for this video. Just try to find out all the gain and uh, impurity or entropy in the previous table which I shared with you. In the next session of decision tree, we are going to discuss Gini impurity. Gini impurity. That is also again an important topic, and we are going to discuss pruning and all in for decision trees in the next session. Just let me know, guys, in the chat section if there is any question. Let me know, guys, in the chat section if there is any question. Okay, so that's all from my side, guys. We are going to continue in the next session. Thank you. Thank you for joining.